Okay, guys, so today we're going to be talking about gas laws again, but this time we're going to be concentrating on how to do involving involving the gas laws. Okay, a couple of caveats before we get started here. I just want to mention a couple of these things. So, um, temperature always has to be in Kelvin whenever you're doing any of these calculations. Okay, so always must be in Kelvin. Kelvin must be in temperature must be in Kelvin. Okay, now volume volume typically can be at any units. However, it has to be in liters when we're doing the ideal gas law. Okay, so we're going to look at a bunch of different laws today. All of them, the volume doesn't matter until you get to ideal gas. Okay, we need to have the volume in liters when we talk about ideal gas law. Okay, next, pressure. Pressure can be anything for the part. However, again, when we get to the ideal gas law, it has to be an ATM. So ATM when we talk about ideal gas. Okay. No, I didn't mention N here. N is just number of moles of gas, and that doesn't change. It's always the same unit, so just always number of moles. Okay. When we do the ideal gas law, there's a constant in there. There's a constant in the ideal gas law, and that constant is called R, the ideal gas constant. It is always 0.0821 liter ATM over Kelvin mole. Okay, now that is the units we're going to use. This is the R value we're going to use for ideal gas law. There are other R values dependent on the units, but we're just going to try and keep it simple and keep it as liters, ATM, Kelvin, and moles. Okay. Other things that we got to know is that standard pressure is 1 ATM. Okay. Standard temperature is 273 K. You often see it written as SCP. Standard temperature and pressure. So standard temperature and pressure again is 1 ATM, 273 K. So keep that in mind. Always keep that in mind. All right. The other thing you need to know is how to convert between all these different units of pressure, because sometimes they give you a unit of pressure that you can't use. You have to convert it. So you have to know all of these. You always have those on a quiz or test, the conversion factors there. Okay. Another thing is 1,000 milliliters is 1 liter. And if you ever see a centimeter cubed, that's equal to 1 milliliter. Okay. So with all those things said, let's look really briefly at all the laws we're going to talk about here. So we're going to talk about Boyle's law. We talked about these ones we talked about last time a little bit. Okay. And then we're also going to talk about these ones here. Dalton's law of partial pressure, Graham's law of effusion diffusion, and ideal gas law. Okay, so let's start really quickly. Boyle's law. I'm not gonna talk too much about this, but Boyle's law, Charles' law, Gay-Lussac's combined gas. Okay, we talked about all these already. All right, we talked about all these already. Boyle's law is P1 V1 equals P2 V2. Charles is V1 over T1 equals 2 over T2. And Gay-Lussac's is P1 over T1 equals P2 over T2. And combined is this right here. Okay, so with that said, let's do a problem or two for each. Let's do a problem for each one. So I'm going to go to the work I gave you here, this worksheet. Okay, so you'll notice that there are some numbers in parentheses here. That's the answers. I give you the answers just to make this easier on you so you know if you're doing it correctly. Okay, so for this first one, all of these problems I always like to write out like what we're given and what that means. Okay, so here Boyle's law is P1 V1 equals P2 V2. Basically what we're saying is that initial pressure times initial volume equals the final pressure times final volume. So here it says a gas occupies 12.3 liters, so V1 is 12.3 at a pressure of 40 mmHg. So pressure 1 is 40 mmHg. Okay, Now we want to know what is the volume. So V2, we don't know what that is. We want to know what it is. So what is the volume? And the pressure's increased to 60 mmHg, or millimeters of mercury. Okay, so these are this is what we have. We have V1 equals this, P1 equals this, V2 equals that, P2 equals that. I highly encourage you to do that. Lay out each one of your variables so that when you plug it into the equation, you know where they go. So P1 is 40, V1 is 12.3, P2 is 60, and V2 we don't know. So I'm just going to write V2. So we're solving for V2 here. We got to figure out what is V2. Now this comes down to our algebra skills. If you struggle with algebra, you're going to have a lot of struggles with a lot of these problems. Okay? But essentially we're solving for V2, so divide by 60, divide by 60. 60 cancels out, we get V2. V2 equals 40 times 12.3 over 60. And you should get 8.2 liters. Okay, next one, Charles' law. So for Charles' law here, we have volume and temperature. So if you remember, Charles' law is V1 over T1 equals V2 over T2. Okay, so we want to find the decrease in temperature when 2 liters at 20 degrees Celsius. So the initial volume is 2 liters. The initial temperature is 20 Celsius. The initial temperature is 20 Celsius. And then the final volume is 1 liter. And the temperature, the second temperature, we don't know. Okay. Now, a little bit of a problem here is that our temperature is in Celsius. We need to convert that. We need to convert that to Kelvin. So in order to convert to Kelvin, we just add 273. So we get 293. Okay, so V1 is 2 liters. T1 is 293. V2 is 1 liter. And T2 we don't know, so I'm just going to write it as that. And you don't need the units. I don't care if you write the units when you do this. I'm just going to leave it as that. Okay, you either have to write the units when you're doing it this way. If you're just doing it this way, if you're just writing this, I need to see units. If you're writing this first, then you can just write units with that. The reason I want to see units in your work here is because I want to make sure that you're remembering to convert to the correct units. Okay. And again, here, the correct units is Kelvin temperature. Kelvin has to be temperature. Okay. Okay. So now, sometimes people have trouble solving for the ones that are on the bottom here. And I understand, but it's really, really simple. What you do is you cross multiply. So 2 times T2 equals 293 times 1. So you cross multiply and you set them equal to each other. Okay? And now you're solving for T2 here. So divide by 2, divide by 2. Okay? And then T2 is equal to 293 over 2, which is 146.5K. Okay, next one. Gay-Lussac's law is pressure and temperature. So P1 over T1 equals P2 over T2. Okay, again, here temperature needs to be in Kelvin. So pressure 1 is 1 atm. It's tricky to sometimes read these. You got to kind of practice and just kind of get some wrong. And so it says determine the pressure change when a constant volume of gas at 1 atm is heated from 20. So from T1 is 20 degrees Celsius, and then P2 is we don't know, and then T2 is 30 degrees Celsius. And again, we're converting those to Kelvin, so add 273, add 273. Okay. Next, all right, P1 is 1, T1 is 293, P2 we don't know, T2 is 303. So solving for P2 here, we cross multiply, so P2 times 293 equals 303 times 1. Divide by 293, divide by 293, P2 should equal 1.0348. Okay. All right, next. This one, the next one is this combined gas law. It's a little bit trickier because we're going to deal with 3 different variables now. And this time we're including moles of gas. So not moles of gas. It's P1, V1. Oops. It's going crazy. Okay, P1. Okay, come on. Cooperate here. P1 over V1 over T1 equals P2, P2, P2. Okay, so don't get discouraged here. Don't get scared. It's just we're adding another. We're doing 3 variables here. So don't freak out. But again, the only thing we have to make sure is in the correct units is temperature. Temperature needs to be in Kelvin. Everything else, you just have to make sure all the volumes and the pressures are the same. Okay. So gas has a volume. Volume 1, 800 milliliters. At a temperature of negative 23 degrees Celsius. And a pressure of 300 torr. Okay. What would the volume be? So V2, what would that be if the gas went to a temperature of 227 degrees Celsius and pressure of 600 torr? Okay. So again, we have to convert these temperatures. We have to convert them to Kelvin. So add 273. You have a negative, so it's really just like subtracting that from there. So it's 250 Kelvin. And this one, 273 plus 227 is 490. Oh, that's 500. Because 273 gets 500 Kelvin. Okay, we set it up. So it's P1 V1 over T1. So P1 is 300. Ugh. Computer is not liking me at the moment. So 300, come on, times 800 over 250 equals P2, 600, times V2 over 500. Okay, again, we can cross multiply if you want, or we're really just doing the opposite of whatever we're doing here. So it's going to be 500 over 600. That will cancel. That will cancel. We do it to this side. We got to do it to the other side. So hold on 1 second here. So then 500 and 600. And if you do all that math, you should get 800 milliliters. All right, you know what? I'm going to stop there, and I'm going to make another video on the ideal gas law and Graham's law of diffusion, as well as the Dalton's law of partial pressures. I'm going to do that after. Okay.